Greetings to all. I am handling basics of biomedical instrumentation through this video class. Our subject code is OMD 551. So in the video class is a third unit video class. So it is a second video for third unit class. So in that class we are going to see about impedance matching circuit and then isolation amplifier in third unit. Okay. So first impedance matching circuit. So it is one of the very important question. It may be asked in university question. So first, what is the impedance matching circuit? Instrumentation amplifier is a kind of differential amplifier with additional input buffer stages. The addition of input buffer stages makes it easy to match the amplifier with the preceding stage. Instrumentation are commonly used in industrial test and measurement application. The instrumentation amplifier also has some useful features like low offset voltage, high CMRR and high input resistance and high gain, etc. The circuit diagram of a typical instrumentation amplifier using operational amplifier as shown in figure. That is, this impedance matching circuit is available for instrumentation amplifier because we widely use instrumentation amplifier in so many applications. So here impedance is going to match in instrumentation amplifier means it can able to produce in a precious output. That's why we are going to match the impedance. The impedance matching circuit diagram is shown in figure. Here A3 is a main amplifier. In the amplifier we are going to match the impedance. So this impedance will be matched through some of the auxiliary operational amplifier and then using some of the resistance circuits. That is, B3 is a inverting terminal is input is obtained from the first operational amplifier. The first operational amplifier input is B1 and the output will be processed, that is the required range of the output will be processed through the resistance arrangement, that is R and R2, similarly RG. Similarly, non-inverting input is obtained through second amplifier. The input is B2, also the output is processed through this resistance R2 RG. After the proper matching of the first amplifier output and second amplifier output, the output is given to the third stage amplifier. So in that manner we are giving the input means we can able to obtain the very accurate output in the A3. Now we are entering into how the impedance are get matched. So this is the equivalent circuit of the previous diagram. Here the main amplifier, this main electrode, this one. So using these two electrode configuration, that is amplifier configuration, we are going to match the impedance of the main electrode. So the working of impedance matching circuit, a circuit providing an output based on the difference between two inputs is given in the above figure. In the circuit diagram, operational amplifier labeled A1 and A2 are the input buffers. Anyway, the gains of this buffer stage are not unity because of the presence of R and RG. Operational amplifier labeled A3 is wired as a standard differential amplifier. R3 connected from the output of A3 to its non-inverting input in the feedback resistor. R2 is the input resistor. The voltage gain of the instrumentation amplifier can be expressed by using the equation below. Operational amplifier A3 working as a differential amplifier. The output voltage expression of differential amplifier V0 will be equal to R3 by R2 V2 dash minus V1 dash. V2 dash and V1 dash is nothing but the voltages obtained from these two amplifiers, that is R3 and R2. R3 and R2 is the resistor placed in that place and in that place. V2 dash and V1 dash is the output obtained from the first and second amplifier. So the final output of main amplifier V0 will be equal to R3 by R2 V2 dash minus V1 dash. So we also know according to the basics of inverting and non-inverting amplifier output equation, we can able to write V1 dash will be equal to minus R1 dash I plus V1. Similarly, V2 dash will be equal to R1 dash I plus V2. Then we are going to substitute these V1 dash and V2 dash in the first equation. So before that we know I is equal to V by R. Here the V is coming from true amplifier. That's why we can able to write V2 minus V1 by Rg. Substitute equation 2 and 3 in V1 and V2 means, so V1 dash, so V1 dash equal to R dash I plus V1. So R dash, instead of I we can able to write V2 minus V1 by Rg. So V2 minus V1 by Rg and then V1. So this R dash will be going inside and the equation became like that. And then after here we are having two V1 terms, then it will be taken out and the remaining term will be written and then V1 dash obtained like that. Similarly, the I also substituted in V2 dash, and after inserting the R dash in two terms we can able to write V2 dash in that manner. So now we are obtaining V1 dash and V2 dash, then it will be substituted in the main equation. So after substituting, V0 is equal to R3 by R2 and V2 minus V1 will be substituted. Here is a V2 term and then V1 term. Minus V1 term, this minus and this minus became plus, and then this plus will be converted into minus. Then our equation will be like that, and then we are going to simplify it, that is R2 by R1, then R dash by Rg. Here R dash by Rg also available, R dash by Rg also available, then V2 minus V1 came. Similarly, 1 plus R dash by Rg also available, 1 plus R dash by Rg also available. It will be taken outside, and then the remaining term is V2 minus V1. This is the overall output equation for after getting the impedance be matched. Okay. So if need a step up for varying the gain, replace Rg with a suitable potentiometer. Instrumentation amplifiers are generally used in situations where high sensitivity, accuracy and stability are required. Okay, so then we are going for isolation amplifier. So then we are going to see about the next topic. The next topic is isolation amplifier. So first we are going to see about what is meant by isolation amplifier and the block diagram of isolation amplifier. Then what are the types of isolation amplifier are available. Okay. So first, what is meant by isolation amplifier? For safety, it is important to protect the user from the hazards of electrical shock. Electrical shock can always present a safety risk with electrical circuits, and it is important to consider the problem seriously. It is worth highlighting that it is current, not voltage, which is a real hazard here. Current flow in tissue can cause excessive resistive heating, leads to burns, electrochemical heating and electrical stimulation of neuromuscular system. Isolation amplifier can be used to break ground loops, eliminate source ground connections and provide isolation protection to patient and electronic equipment. In a biopotential amplifier, the main purpose of the isolation amplifier is the protection of the patient by eliminating the hazard of electrical shock resulting from the interaction among patient, amplifier and the electric devices in the patient environment, especially defibrillators and electrosurgical equipment. It also adds to the prevention of line frequency interferences. So then the block diagram of isolation amplifier. First, the input will be amplified and then it will be modulated. It will be given to the transformer of the primary. So we are having isolation barrier between transformer primary and secondary. So once we are going to protect the input means we are giving some additional signal, that is photodiode or transformer secondary. The isolation barrier is available. So if we are going to protect the input from transformer without allowing transformer secondary to primary to secondary means this isolation barrier will break the incoming of secondary primary to secondary. Then once it will be the barrage give the proper isolation means the primary signal will not enter into the secondary. If it is enters means then the original wave will be demodulated and then amplified, we can able to obtain the result. If there is any interference, the input from power line electromagnetic interference means it will be buried through the barrage isolation. So it is the general block diagram. Now we are going to see about what all the types of isolation amplifier are available. So three isolation amplifier are available. First one is transformer isolation, and then optical isolation, and then capacitive isolation. So first one is a transformer isolation. The transformer approach is shown in figure. So it uses either high frequency modulated or a pulse width modulated carrier signal with a small signal bandwidth up to 30 kHz to carry the signal. It uses an internal DC to DC converter comprising of a voltage 20 kHz oscillator, transformer, rectifier and filter to supply the isolated power. This is the basic diagram of transformer isolation. Here we are going to provide the isolation through this transformer circuit. So the patient signal will be amplified, and once we are giving the signal to the transformer barrage circuit, then only the signal will be received to the electric circuit and then it will comes to mains amplifier. Here also we are having one barrage. Once when the barrage will be excited, then only the signal is received from the secondary to primary. In that manner we are going to give the electrical isolation between patient input to the output circuit. Then another one is the optical isolation. So here instead of primary transformer circuit, we are going to provide the isolation through optical manner. Isolation could also be achieved by optical means, in which the patient is electrically connected with neither the hospital line nor the ground line. A separate battery operated circuit supplies power to the patient's circuit, and the signal of interest is converted into light by a light source LED. The light falls on a phototransistor of the output side, which converts the light signal again into an electrical signal having its original frequency, amplitude and linearity. Number of modulator and demodulator is needed because the signal is transmitted optically all the way. This is the circuit diagram for optical isolation. Here the patient signal will be amplified and it will be given to the ECG. It will be shown in the ECG form of output when the opto isolator give the signal to this arrangement. Once the opto isolator give the signal, then only it will send the measured waveform to this phototransistor. Otherwise, if there is any interference or malpractice occurs means it will not send the signal to this phototransistor arrangement. In that manner we are going to give the isolation. Then another one is a capacitive isolation. The capacitive isolation means is we are uses digital encoding of the input voltage and frequency modulation to send the signal across a differential capacitive barrier. Separate power supply is needed on both sides of the barrier. Signals with bandwidths up to 70 kHz can be connectively handled in this arrangement. So here the input signal will be modulated, but here we are having the capacitive isolation. Once the capacitive isolation give the signal to the modulator, then only it will send the input signal to the demodulator circuit, from which we can able to view the output signal. If there is any fault occurs means the capacitive isolation isolate the input to the output signal. Okay, so this is the capacitive isolation. So we studied about transformer isolation, what is meant by isolation, how it will be obtained, then the block diagram of isolation, then the types of isolation. So in next class we are going to see about the next topic. So in this video I completed so what is meant by impedance matching circuit, how it will be obtained, and then what is meant by isolation, how it will be obtained. Thank you students.